Thank you very much, everybody, for joining us today. I am Nick, I'm one of the technical staff here at Massons Healthcare, and I'd like to welcome you all to today's educational webinar. It is titled Click Medical Product Updates. It is hosted by Massons Healthcare and Click Medical, and today's webinar will be screen recorded and made available online after today's event. Massons has been a proud partner with Click Medical for many years, and we continue to provide adjustable solutions to Australia, New Zealand, and Singapore. Today, we do have the pleasure of having two speakers with us, Joe Mahon and Mike Martin. And just letting everybody know that all attendees are on mute with your videos off. If you have questions, please type those in the Q&A section, and we will attempt to address these after Joe and Mike's presentation. Before I hand the stage over to Joe and Mike, I'd like to share some info about them. Joe Mahon, full disclosure, is kind of my cousin. Joe is also a prosthetist with over 25 years of technical and clinical experience. He pioneered and patented the RevoFit system. It's the world's first adjustable prosthetic technology, and Joe has 10 plus patents to his name and has lectured in over 20 countries on adjustable prosthetic designs and fabrication techniques. When he's not in the lab teaching or traveling, you can find him in the mountains or on a river, unless it's snowing, which case you will definitely find him on his skis. Mike is a registered prosthetic technician with over 15 years of experience. He has built hundreds of devices over his tenure and has managed a state-of-the-art lab for 8 years. Mike made a career move in 2019 and became one of the territory sales reps for the largest O&P distributor in the US. In 2022, Mike joined the Click Medical family and operates on both the sales team and the technical staff in his roles as technical and sales support specialist. When Mike is not in the lab or on the road, you will likely find him fly fishing, snowboarding, or on the pitch scoring goals. We hope that you find today's information helpful. If you are in Australia, New Zealand, or Singapore, and you have questions relating to today's content, please reach out to our team at Massons Healthcare. If you are based in other regions of the world, please reach out directly to Click Medical, and they will guide and provide the information required accordingly. Now, without further ado, I'll hand the stage over to Joe and Mike. Thanks, guys.
Thank you, Nick. I will get started. We've got a decent presentation here for you, about 55 minutes long. So we'll take up most of this time here. All right, so today we're going to talk about Click Medical adjustable solutions, orthotic and prosthetic. We lean a little bit more heavily on the prosthetic side just because I'm a prosthetist, not an orthotist. But we do have some orthotic support in the crowd here, so in case there's some questions, we can field them as well. Traditionally, adjustability for a lot of people has been kind of a tool in the quiver that they could use when they have a difficult case. And we happily accept that challenge of you've tried everything else and now try adjustability. But we really think that adjustability can be for a lot more than just your most difficult cases. We recently got a code in the United States for our system, describing it as a mechanical volume management system, very similar to elevated vacuum here in the States as well. Same kind of verbiage. Obviously, that's a elevated vacuum volume management system. But we really think, like volume management or like elevated vacuum, this can be used for a lot of people for a lot of different indications. We use it a lot for volume management. It's also used for rotation. It can be used for anti-levering. We can use it for expansion, downing and doffing. There's a lot of reasons for adjustability, and hopefully we can inspire you to use our products and to look and think about them in a little bit of a different way. The new Click Reel was introduced this year, and there's a few differences between this and the BOA reel. We still have the low power BOA reels. Those are still available, and we have those for RevoLock lanyard kit, and we have those also for our quick fit lacers and straps. But for the high power reel, we now use the Click Reel. It is a bidirectional reel, which means that tightens in one direction and loosens in the other, as opposed to the old system, which was tighten in one direction and then pop to release. The tightening and loosening bidirectional, people are really liking that feature. They like having the ability just to back it off just a little bit and not start from zero if they have to loosen up their socket a little bit. The new system is stainless steel for the most part. All the internal components are stainless. If you do go in the salt water, which obviously in your part of the world, there's a lot of people in the ocean, make sure you rinse it out with fresh water after use. And I would, really submerge that dial in some fresh water if you could after using it in salt water, just because that salt is pretty corrosive. You may want to add a little drop of oil if you do a lot of salt water activity. You may throw a drop of oil in there on occasion just to keep those metal parts lubricated. The click reel operates in a couple different modes, and I'll touch on this briefly. It can operate in the power mode, which is when you leave the red plugs in the bottom. That's very simple, micro adjustability, 7-to-1, mechanical advantage, righty-tighty, lefty-loosey. Very simple, very straightforward. We use power mode for pretty much all prosthetic RevoFit applications. So if you're doing panels, small gaps, we're going to leave the dial in power mode. We don't use a lot of lace when we're in that mode. When we're doing panel adjustability or gap adjustability, that's why we can leave it in that mode. If you need to use a lot of lace, then you're going to want to use the shift mode, in which case you would pull the red plugs out of the dial, and that allows the dial to shift and unshift between macro adjustability and micro adjustability. But it automatically shifts and automatically unshifts. Okay, so something to keep in mind. And we use that when we're talking about using more than 3 inches of lace per application. And we'll get into this a little bit more on the next slide as well. We were able to lower the profile of the new dial by 4 mil, and then we guarantee the dial for life. So any issues that you have or any problems that you have with the dial, the life of it's guaranteed for the life of the device, not the life of the patient, obviously. Return it, and we'll give you a free refund on that dial. A little bit more of a breakdown on the different modes of the dial. And this is different, and I really want to make sure that you guys understand this. There's 2 different modes. Like I said, most prosthetic applications use power mode. Leave those red plugs in place after you lace it. And that's for a device that's got 1 to 3 panels, a hinge, or a gap that's less than 3 inches. And that's just a very simple righty-tighty, lefty-loosey, and the dial will click. Like I said, if you need to use a lot of lace, then you would pull the red plugs out. So it looks like the bottom dial there. And now you're going to have fast lace uptake, which is quiet 1-to-1. And then it shifts into the power mode and it'll start to click. When it starts to click, don't stop turning it. You have to keep turning it. Okay. Some people will get 1 click and then they'll pause and then they'll do 1 more click and pause. If you do that, you're not going to be able to shift the dial. You have to turn the dial in order for it to shift. And if you do it click by click by click, it's never going to happen. Okay. So turn the dial. You got to, it's going to click a couple times and then it's going to shift up into 7-to-1. Then once up into 7-to-1, you can forwards and backwards. And then once you release all the tension off the lace, then that's when it unshifts back into the 1-to-1 mode. So a few things to consider when you're, lacing the system, when you're delivering the system. Do I need a lot of lace, or am I just using a little bit of lace? That's kind of the main question there. For fit solutions, RevoFit, I think everyone's pretty familiar with that. That's our lamination kit. A new kit that's fairly new, came out in April, is our Revo Surface. That's our tool kit. That's something that can be added to the outside of a device. RevoFit is something that's laminated in between the layers. We use RevoFit for orthotic applications, obviously prosthetic, upper and lower. We're using the RevoFit lamination kit. Revo Surface is a kit that you would use if you were printing a device. If you're printing, we'll give you the CAD for the collar. That way you can integrate the collar right into the piece, the print. We don't give you CAD for designs and for lace routing and all that. That's on you. That's up to you to design and to figure out what are you adjusting and where. Same rules apply. You still have the same quarter rule. You're still bisecting panels and crossing over trim lines perpendicular. those same rules apply if you're laminating or printing. Just make sure you follow that when you're designing up the CAD. Our Revo lock solutions are for suspension, and we have 3 kits here. The kit in the middle is new. That's coming out very soon. I think a week or two we'll have these in stock. Currently, the Revo Lock Align, which is the kit on the left, and the Revo Lock 4-hole, the kit on the right. Those are kits that use the click reel. With those kits, we also have what's called the slider, which we'll talk about in a second. And then with those click reel kits, the Revo Lock click reel kits, we also have the snap and threaded insert. The snap is a quick release way to access and attach the lace to your liner. It's got a push button on the side, and it slides on and slides off. You got to push the button to release it. So the Revo Lock 4-hole and the Revo Lock Align both include that snap threaded insert feature. The kit in the middle is the Revo Lock Lanyard V2, and we've had a Revo Lock lanyard for 5 or 6 years, I think, maybe longer. And we discontinued that kit because they no longer made the M3, the BOA M3 dial. Those dials that we used on that kit are no longer available. Same for the kits for the H3 dials, the RevoFit kits. Those old BOA dials are no longer available as well, only for warranty purposes. But the Revo Lock Lanyard V2 uses a BOA dial. It uses the old threaded insert. It uses a small distal housing, and the distal housing, I believe, is 25 millimeters tall and 35 millimeters wide, so very low profile, really small distal housing. So for those long limbs, or you don't have a lot of space for a locking unit, that's our lowest profile locking unit that's available. Some people thought that the Revo Lock 4-hole and the Revo Lock Align were too complex because of our slider feature that's part of the kit. If you want a simple lanyard solution, we still suggest the Revo Lock Lanyard V2 kit with the BOA dial. Very simple. It's a simple one-to-one mechanical advantage. You don't have any power with that kit, but you do have a very simple one-to-one. You turn the dial. One turn of the dial is one turn of the spool. If you need more power, then you would use the Revo Lock 4-hole kit and the Revo Lock Align kit. Okay. This is what the lanyard kit looks like, and this is probably the one that I think your market in Australia and Singapore and New Zealand, I think you guys will probably gravitate more towards this kit. It's a lower price point. It's got uses a BOA dial, which some people prefer for their lanyard suspension systems. You can see that it's got a threaded insert that has O-rings on it, and those O-rings on the threaded insert eliminate any kind of airflow that would occur as the patient's walking. Sometimes with some of those strap systems or lanyard systems, there's airflow with every step. With our system, we didn't want to have that whooshing or hissing sound as they walked, so we included some O-rings on that threaded insert. And then there's the tubing, and we use the high-capacity lace, metal threaded insert, and then the metal spring wire. That metal spring is for exiting out the side of that distal housing and routing the tube up the side of the socket. We use that metal spring so that we don't kink the tubing. And that's really the only reason we use that metal spring. You can shorten it if you need to. You don't have to use its full length. You just want to make sure that when you exit out of the side of the distal housing and route the tubing up the side of the socket, that you don't kink it at that turn. So pretty important. Revo Lock, we use these for patients that are bulbous, that have a difficult time, engaging a pin lock. We use this for patients that are kind of fluffy and have a hard time getting all that, fluff down into their socket. This, lanyards elongate the limb, it pulls them into position. If you have patients that struggle aligning a pin lock or getting their liner on the same way every single time so that they can get the pin lock engaged. This may be a system for them. This system allows patients to don their prosthesis while they're seated, which, from a safety perspective, we like patients, having their legs attached, securely before they get up and start walking. Sometimes with mechanical pins and things, would have patients over the years that, they'd stand up and they think their leg is on and they take a step and, off it goes. So this is a secure system, it's on, and to release the system, you either have to unthread it or you have to push the button on the slider. So the Revo slider, this is an addition. This is a part of the Revo Lock kit, and it can be in addition to a Revo Fit kit. Okay, the Revo slider, it comes with all the Revo locks, and what it does is that it overrides the unshifting feature of the dial. Okay, so the dial, like I explained, you turn the dial, it's quiet, it's 1-to-1. It will shift into the power mode. Once it's shifted and fully shifted, you can then take the slider and slide it down, and now the dial is locked into power mode. You can still tighten it and you can still loosen it if you need to. You're not going to be able to fully release the lace until you slide up onto the slider, until you slide the slider button up. Okay, so this allows the user to quickly pull in their lace. Once it's shifted, they can then engage the slide, keep it in power mode. So when they are seated and they want to release some of the distal pull that's happening for a lanyard system when they're seated, they can simply turn the dial backwards a couple of turns and release some of that distal pull without fully releasing all of the lace. Okay, they're not starting over. Like the old system, you'd pop the dial and all the lace would release. So this just releases the tension. You can micro adjust forwards and backwards. To fully release the lace, you have to slide up that button. Okay. We also use the slider, and it can be addition to the Revo Fit kits. And people are using this that do PDEs or bivalve cuffs. And essentially what they're doing is they're adding the slider to the Revo Fit. So apparently, and I'm not an orthotist, but some people like to wear these braces kind of loose. And then some people like to wear them incredibly, incredibly tight. You can leave the red plugs in the dial and just operate this in power mode. However, you're going to be turning the dial a lot, okay? Because it takes up lace very slowly. If you want to have full function of the dial, you're going to pull the red plugs out and you're going to have full function. So it will shift and unshift. It will go into power mode. And then you have the slider button to manually override the unshifting and keep you in power mode. So if you like to use the brace kind of slightly loose, you want to make sure that you have shifted it into power mode. The system is tight. You slide the button down. And then if you want to back off some of the tension, you want to wear it a little bit loose or a little sloppy, you can just turn the dial backwards a couple of clicks and release some of that tension without releasing all of the lace, okay? To release all of the lace and open up the system, you would have to then push on the slider and disengage the system. As you can see here, I've put a little bit of a key notch in this cuff, and that key notch helps keep that anterior shell positioned in the transverse plane, okay? It doesn't allow that anterior shell to migrate up and down. Those little micro movements sometimes can cause that lace to fray prematurely. And so when you have a cutout like this little key notch that I put in there, that really helps save that lace and allow it to last a little bit longer. The other thing that a key notch does is it allows the user to basically don this with one hand. They don't necessarily have to hold the anterior shell in position and then tighten up the dial. They can simply turn the dial and that key notch will find itself and lock itself in to that posterior shell. So something to consider if you do a lot of PDEs, or dynamic braces or cuffs. You're going to want to install the slider, and you're going to want to use a key notch. In my opinion, use a key notch to keep that anterior shell from migrating up and down. In this situation here, this design, we're using the A and the C ports for our lace exits. And then we've got the slider routed into port B, the B port. And that's how you control the slide there. As you can see, it's a double turnaround on the anterior shell. You can see where there's 2 turnarounds. I've got another slide of another cuff later down in the presentation that has 1 turnaround. I'll show you how they do that. Quick fit lacer with the BOA dial. Like we said, we still have access to these low-powered BOA dials. These are all 1-to-1. Okay, there's no power here, but for soft goods, they work great. For people that have stroke or any kind of paralysis, these dials work fantastic. We see a lot of these applications for leather gauntlet AFOs, shoes. We also see them for some orthotic applications as well. Quick fit straps and buckles. These are magnetic buckles. They are sold separately from the strap. We use these, you see these on AFOs, body jackets, upper limb, harnessing, etc. The dial comes with a hard grip, and some people like a soft grip, or some people have dexterity issues. So we have these grip packs that you can buy. They come in packs of 5. And I really like the power grip. It's quite soft, and it allows the user really to turn the dial without really using their hand. They can turn the dial just by rubbing it along their leg or across their other arm, or they can rub the dial along a flat surface. That power grip was designed and built to be very tacky, so it's easy to grab. And it's got these flat spots on the grip so that you can rub it across the flat surface of a tabletop, and you can still tighten and loosen that dial. So for upper extremity patients that don't have hands or fingers, or patients that have weak hands or paralysis or any kind of missing digits, consider adding a power grip to their dial. For the techs out there, we are doing more and more single shot laminations for Revo Fit and for Revo Lock. Happily share some more information with you. We only do this really for simple Revo Fit solutions, so like a simple single panel. But when you do it in a single shot lam, you can reduce a lot of a lot of resin, a lot of materials, and a lot of time. You can take about an hour off of your time if you do it single shot as opposed to a double shot. So we're doing more and more of these in our lab. We're seeing more and more out in the field. People are getting more confident using single stage. You just want to make sure you secure that tubing down. We use little strips of 1-inch carbon tape that we spray glue on one side, and we just use that to secure the collar. We use that to secure the tubing, and then we make sure that everything stays put while we're laminating, make sure it doesn't migrate anywhere. Our new click kits can be used really with any kind of fabrication method. Check sockets, laminated sockets, 3D print. Like we said, if you're doing any printing, make sure you reach out to us and we can get that CAD for you for your collar. Types of adjustability. When I teach adjustability, I'm usually talking about panels, gaps, and hinges. And panels are kind of where we started, very targeted, very precise. We're trying to deflect the plastic inwards, and narrow panels do that really well. Wide radius panels don't do that very well, okay? So just keep that in mind. When you're designing something, don't put a large, 4-inch wide, panel on a transfemoral. It's too wide. Narrow those panels. That allows for easier deflection of the plastic. The patient can feel it faster, sooner, and less stress on the overall system. But we're doing panels for upper limb to help with rotation, help with heavy elbow and wrist and hand units. We're doing it obviously for transtibials, transfemorals. We like to put multiple narrow panels to kind of isolate the muscle belly and to lock onto the femur. And then you can get creative in terms of dial placement. We've seen dial placements, on distal ends of sockets, anterior portions of sockets, you name it. You can put the dial pretty much anywhere, wherever it fits. More importantly, where can the patient, can they reach it? Can they get to it? That's the most important thing. Transfemoral, I like this design. Narrow panels, again, these are much more effective than if they had one large lateral panel. One large lateral panel that's 4 inches by 6 inches would not be effective. You're going to fight up against your flexible insert, and the patient's not going to feel it, and they're just going to think that the system doesn't work. So let's get a good outcome here. Narrow up those panels. Make sure you're deflecting the plastic. Make sure you're using the right interface material. Make sure you're using plastic that's actually going to flex. Okay, we're talking about 3 millimeter plastic, 4 millimeter plastic thickness. You don't want to go much thicker than that because it's going to be hard to flex. Don't use anything rigid because they won't be able to feel it. Okay, so we want them to feel it. We like rolled silicone. We like ProFlex with silicone. We like Keezy cones, Kerbel Optec Flex. There's a lot of great soft plastics out there. What do panels do? Well, we did a study with the VA, and they can do quite a bit. Transtibial, we've got a 3-panel transtibial that we scanned through the VA here, and they're just measuring compression, and they're able to get about a 16% reduction with when the 3 panels were fully engaged. So they measured the socket at 0, no compression, and then they measured at full compression with all the panels maxed out, and they got about a 16% reduction. So that's pretty huge. We weren't able to measure expansion because to measure expansion, the patient has to be wearing the leg, and you can't scan inside when the patient's wearing it. So we weren't able to scan expansion, but I would assume that we're going to get 4 to 5% of expansion with that flexible plastic, expanding out into those areas of adjustability. And if that were the case, then we're talking about a 20% volume accommodation for a 3-panel type of transtibial. So that's quite a bit. We haven't done a study with transfemoral. Obviously, it all depends on the areas of adjustability versus how big are the areas of rigid. But 16% we think is a pretty fantastic volume accommodation number. Now, what I said about all those narrow panels, you can take that information and you can just toss it in the garbage for this slide, okay? Sometimes you have wide radius panels when you're talking about suspension, when you're trying to lock onto a bone. Sometimes you have wide radius, okay? Typically, these don't have a flexible insert, or if they do have a flexible insert, the flexible insert is split, okay? It's non-continuous. So you can have these with flexible inserts, but that flexible insert either needs to be out of foam or it needs to be split somewhere, okay, for them in order for them to don and doff. But these have wider radius, obviously. These are containing and suspending, locking onto that bony anatomy. So sometimes, yes, you do a wide radius panel, but typically that's only for that's typically for a joint disarticulation. So, and that doesn't have a continuous flexible insert. Just a few more examples of some rotation plasty and PFFD. I think that actually the one on the left there is actually from Australia. I believe that patient was Australian that came from Massons years ago. Now we'll talk about some gaps. So this is more for global fluctuations. Originally, we were doing posterior gaps in the hamstring channel. We would save those pieces of laminate for large gaps. Anything that's more than 2 inches, we would save those pieces of laminate and insert it while we're lacing, just to protect that flexible from getting sawed in half by that lace. That lace is pretty strong, and that plastic is pretty soft. So the lace is going to win every time. So if you do have to run lace over plastic, either run it through some tubing, just take a piece of tubing and cut it, and just as you're lacing it, when you get to that gap, just run it through some tubing, just so the lace is the flexible is touching the tube and not the lace, or save those pieces of laminate. This is another gap design with a panel. Two different sockets here. So the one on the left's got a long lateral gap. I quite like this design. This has got some great circumferential compression for that middle to proximal half of the socket. And then they've got a pretty large medial panel there, probably a little wider than I would like to see, just because you're going to fight up against that flexible plastic. If that happens to be a more flat spot under that big panel rather than a radius, then I would like that more. But if that's the case and that's the panel, then you would make sure you want to fill the trough, the deep part of that panel. You want to make sure you fill it with some extra foam, and then you skive those edges. That helps deflect that plastic a little bit better. On the right side, we've got another large lateral gap, which I like. They also have a lateral distal panel, which I would assume is positioned just above the distal end of the femur, just to keep that distal femur off the lateral wall. And then they've got a pretty large anterior scarpus panel, which I like as well. So kind of some different gap designs that include also a panel. Now, you will want to make sure that if you're doing a system like this with panels and gaps, that panels are on one dial and gaps are on the other. Otherwise, you'd have to close that gap before it would engage the panel. And a lot of times you wouldn't want to do that. So if you're doing panels and gaps, they typically have to go on two different systems, two different dials. TT gap designs on the left-hand side, that's for bulbous, really bulbous distal end. The middle and right pictures, this is just providing the patient a little bit of AP squeeze, anterior posterior squeeze. There's a little bit of a foam pad underneath that posterior panel. This kind of compression decreases tibial levering. This can help with some rotation, helps with donning and doffing, allowing it to expand, get it on a little bit faster, and then give the patient a little bit of compression. Now, this is obviously not a panel design. This is a gap design. So the bigger the gap, the more compression they're going to get. And it's pretty simple design, pretty simple setup. Doesn't take a lot of time to install this. Doesn't take a lot of time to set it up. But it does give the patient quite a bit of adjustability. These are partial feet, Les Franck, Chopart type prostheses. One thing just to point out here is the key notch. Again, I like using that key notch. It keeps that anterior shell positioned nicely in the transverse plane. You don't get any migration. It will kind of self-locate it locates itself as you're tightening up the system. Another gap design for upper limb. You got a wristus artic in the white socket and then transradial in the black socket. These are just gaps that we're closing. This is mostly for medial lateral compression and for donning and doffing. Hips, these are, again, we're still closing gaps here. You can see these are all key notched. Both sockets on the left and the right have key notches. These use our plastic lacer, our plastic quick disconnects. These are part of the Revo Surface kit, and these can also be purchased separately. These are our releasing tabs that you grab onto, that unlocks from one side. You can then open the system up, don and doff it. To put it back on, you just hook up those two tabs and then use the dial for compression. One thing about hips and hemis is the ability to have a nice tight socket when you're walking, but also have the ability to breathe when you sit down. So having the ability to expand that socket while they're seated is a huge, huge benefit. And oftentimes these are adjusted with straps. Straps are not micro-adjustable. They're difficult to, you have to drop your pants in order to, loosen up those straps or tighten them. With our system, you can just operate everything through your clothing. And then hinge designs. Hinges are typically used for like bulbous distal ends for people that have, maybe a lot of distal edema. Maybe they had a revision or they're a new amputee. They've got, just kind of a large bulbous circumference on the end, that's larger than the proximal. This is when we typically will do a hinge type of design. It's basically like a panel design, but we try to connect the panel at the bottom. So you can see here, we use some flexible little tabs of flexible plastic, and it's connected at the bottom. And then it just kind of hinges open. The patient dons the prostheses, and then it hinges close. By hinging it at the bottom, we're just reducing some of the tension that's on the lace. And again, we're kind of locking that panel in the transverse plane. It's not allowed to migrate up and down. It can go in and out. It just can't go up and down. So I like hinging, and we use it often for these kind of bulbous people. Like this patient, obviously 5 centimeters larger distally than they were proximal. Without doing a stovepipe, foam configuration, they'd never be able to get this on. So they did add foam to that medial panel after the fact, just to give them a little bit of soft compression. But typically for these types of designs, it's not really about the compression, it's more about the expansion and then the closure for the suspension portion. Some orthotic applications, leather gauntlet, AFOs, obviously very popular. Our quick fit lacer, our shoe kits, and then again, RevoFit on the far right, that's for your PDEs and your more laminated kind of dynamic braces. Sometimes we combine kits. We'll combine a RevoFit and a RevoSurface. So if you're doing a cuff, we've talked about adding the slider and having the cuff and having the different modes of operation. Some people, they don't want to use all that lace for a cuff. And so what they'll do is they'll exit the lace out of the frame, and then they'll add some releasing tabs. And you can see on the right picture, those are releasing tabs. And that allows this cuff, this anterior part of the cuff, they can just unhook those 2 tabs. That anterior shell will hinge open. They slide their foot into position, and then they simply close that anterior shell and then hook up those 2 plastic tabs and then tighten up the system. By using those plastic tabs and those releasing guides, you don't use a lot of lace. If that was all connected, you would have to, that anterior shell would have to open up so much to get that fused ankle through that anterior portion. But by adding that RevoSurface, those guides, and adding those release tabs, you don't hardly use any lace. You use enough lace to grab that tab and to release it, and then the same amount of lace to tighten it back up. So another solution there for those cuff designs, and I know FabTech has played around with this as an option as well for their cuff. I think they've gravitated towards using the slider for all of their PDE cuffs. But just know that this is also an option if you need to hinge something and open up something a lot. This is the other cuff slider combination. And this dial and this design, they're using the B and the C ports for routing the lace. And they're using the A port for the slider. And you can just see how the slider is a little bit differently configured in terms of where it lays on the socket. This one fits nicely just right above the strut. As you can see, there's just a single one turnaround on the medial side there, as opposed to the other example that I showed you that has 2 turnarounds in the front. So a little bit of a different design, same features with the slide. These are, I believe, will be sold with the PDE kits. We don't sell PDE kits, so make sure you figure that one out with FabTech, but I believe the FabTech kits with our system will be having the slider as part of that kit. And then a few more orthotic applications. These are actually some stuff that was from Massons on the far right. Some Fjord and Getz. ankle joints, and then left-hand side, just another orthotic application that's laminated. You can also do adjustable dorsal and plantar flexion. These are actually, this is from an old kit, but you could use a Revo surface for this application. Sometimes these are laminated. Depends on just what you're trying to accomplish here. But by running the lace in front of the joint or behind the joint, you get two different, obviously two different things going on here. We see a lot of people running the lace in front of the joint and using it more for contracture management and night splints. So just wanted to show that and just so you guys can keep that in mind for some more orthotic use. And then quick fit lacer, again, these are added to the outside, riveted on, and we typically don't recommend putting the quick fit lacer on anything that's rigid. But on the right side, obviously that's rigid plastic that they have this on, but it's upper extremity, which is definitely different than lower extremity weight bearing. So I would never put any of these quick fit lacers on lower extremity weight bearing rigid device, simply because those dials are not meant to handle that much torque, that much kind of like ground reaction force that's put on these dials. Our straps, like we said, can be used for orthotic applications, prosthetic applications. We see them a lot in the States for shoulder saddles and shoulder harnessing, for transhumeral sockets. We've got a ton of great education in our Click Academy. We've got Revo Lock, Revo Surface, and Revo Fit modules. So you can go and learn more about design, building, optimizing, expanding it. In the Revo Fit modules, we teach you about panels, gaps, and hinges, the rules, and how to do panels, gaps, and hinges. So if you're new to the system and you're new to Revo Fit, it's a great place to go learn. If you're a technician, definitely a great place to go learn. Lots of great videos. So we want you guys to make sure that you know how to fabricate these. Reach out to Massons. They've got great tech support there. We've also got our stuff online with the Click Academy. We also have what's called our design gallery. So if you go into Click Academy, on the left-hand side, there's a design gallery, and that's like, we've got about 24, 25 case studies. These are PFD documents that you can download or print out. And these case studies, we'll have one like on a dialysis transtibial. We've got one on a rotation plasty and how they built it. We've got one on, upper limb transhumeral sport arm. So we've got different types of kind of unique designs, and it's a great place to go get inspired or go, find a solution for maybe a tricky, complex case. But just want to make sure that you're aware of those case studies and that library of information. That's all I've got. I will stop sharing my screen here. So before I take questions, one thing I wanted to just kind of point out, I think I forgot about when I was talking about the Revo Lock lanyard, is that if you've had some issues with the Revo Lock line or the Revo Lock 4-hole, we do have a retro kit that's coming out that allows you to remove the click dial and insert the Revo Lock lanyard V2 dial, which is the BOA dial. So if you are struggling, you've already built the device, you're having issues, the patient's having issues, it's too complex, or they don't know when to engage the slider, or they just don't want to use that system anymore. Before you remake anything, please reach out to Massons, and we will get you a retro kit so that you can just pop out that click dial, pop in the BOA dial, and they can continue on with their existing device.
Awesome. Thank you, Joe.
Yeah. Sorry, that's a lot of information there.
It certainly
just want
is.
to make sure I cover all the products, make sure everyone's aware of everything, and just kind of showing you some designs and how we use it. I know a lot of you are familiar with this stuff, and maybe this was repetitive, but hopefully you got something out of it. Does anyone have any questions for me?
I think we had asked people to post in the chat if they did. We did not have
Okay.
any come up, but I've got a couple just prompts that I'm thinking in the back of my head, calls that I'm going to get down the road. Can the RevoLock V2 be used for RevoFit applications?
So you're talking about the RevoLock. I just want to just be clear. The RevoLock lanyard.
The RevoLock lanyard V2 with the BOA dial.
With the BOA dial. I know that's
should our customers be using that for RevoFit?
No.
Thank you.
The thing is, it's only a single lace pull. So there's only one lace exit out of there. So there's no way to have any kind of routing like that. So,
okay.
I mean, I'm sure people will get creative and will use it for something. But no, it's not what it's intended for. There's no warranty. There's no guarantee. If you go outside of suspension, then no.
Okay, very good. And the lace port on that new RevoLock, let's see if I can do it. RevoLock lanyard V2 with BOA dial. Does that exit distally like it does on the Align kit?
No, it's the old housing. So it exits out the side, and that's what the metal spring is for, to make that first 90-degree turn to go, up the socket. So no, it doesn't. The lace exit is not distal. It's off on the side, lateral.
Okay.
Yeah.
Okay, perfect. Yeah, I know I fabricated a few, and I just found the distal exit to not be ideal when it comes to attaching things after the fact. But I've always preferred that side exit, so I think that'll be good for all of us.
Yeah, no problem. Yeah, we were trying to eliminate that 90-degree turn, which is why we came out the center and then just kind of make a very gentle turn up the side of the socket. But when we did that, it added length. And people are like, oh, I got to transfer and attach a pyramid or something down there. And that started getting in the way. Some people didn't like the location of it. So that's all been noted. We are working on some V2s of our Align and V2s of pretty much everything already. Even though we just launched, we do have, we're always innovating and always doing things. But if there's concerns, if there's issues, if there's feedback, good and bad, I mean, we want to hear the bad feedback as much as the good, just so that as we're developing and making version 2 and version 3 of these things, that we know from the fields, some of that feedback. So please continue to be, vocal. We want to hear from you. We want to hear from Massons, and so please help us develop better products in the future.
Yeah, definitely. And one question for Mike. When it comes to the slider and fabrication of it, do you have any tips or tricks? I've built 2 myself, and they are pretty straightforward. Just when it comes to where to locate that, how to trim that wire. Do you have any tips, Mike?
Certainly, one thing to pay attention to is just the bridging that the tubing is going to have in between the slider lamination base and the collar of the reel itself. So if you don't go and backfill that area, there is potential for that tubing to pull away from either that slider base or the lamination collar. So certainly you want to be attentive to that detail. And then speaking of ports with these locks, I did want to highlight for the V2. So this is the V2 kit with that BOA reel. If someone's going to be utilizing that retrofit kit, it is going to be important to pay attention to what port the lace is traveling through. There's going to be 2 different retrofit kits. As Joe mentioned before, the V2 kit only has 1 port. So when you are ordering a retrofit type V2 kit, pay attention to either the A or the C port, because there are 2 separate kits.
Cool, thank you. Go ahead,
the
Joe.
RevoLock the Revolock lanyard V2 with BOA dial, that uses the C port. Okay, so when you're building that, in the future, when you get that and you build it, you're going to use the C port. That's what the retro dial is set to, using the C port. Okay. We know that people don't read the instructions, and some people use the A port. Okay. And if they did that, it's okay. We have an A port option. Okay. If they use the B port, then they're totally screwed. Okay. Then they're pretty much out of luck. I don't think we haven't heard of anyone using the B port. Usually it's either A or C. Should be C. C is in the instructions, but like I said, some people just just freewheel it, and so definitely keep that in mind. If you're doing a retro kit, make sure you get the right one.
Okay, thank you. One other question that I had regarding the slider. So lanyard applications, fairly necessary to use it.
Yeah.
PDE applications, CAFO designs, dynamic AFOs, would you put that in that same category of fairly necessary to use it?
Yeah, I would think so. Just because, like I said, some people wear those a little bit loose, and like we said, if there's no tension on the lace, then it can just, it can free spool, right? And typically, if there's no tension on the lace, like a prosthetic, like a panel, you don't want any tension on that. Well, there's no tension on it. It's just going to sit there, okay? But when you have a bivalve or cuff, and you don't have the tension on there, we don't want that to just continually open, right? So that's what the slider is for. So I would definitely say for any kind of cuff, PDE or similar, either you're going to use the red plugs in the dial, and it's going to be micro adjustable, and it's going to be very slow lace uptake.
Mm-hmm.
Most people don't want that because they need to open that up a lot to get the foot through, right? So if that's what you need, for sure add the slider to your Revo fit.
Okay, perfect. And then yeah, just to kind of reiterate, keeping those red lock plugs in, just for everybody, so we're all on the same page. Leave those red lock plugs in, and the slider would not be necessary for any type of safety reason. So
exactly.
Keeping those red lock plugs in is your best bet to keeping that at a good safe device.
Yeah, it's when the red lock plugs are in, it's locked in both directions. You can turn it to the right and it's locked, turn it to the left and it's locked. Yeah. It's not going to unshift. Yeah. So that's your safest mode. If you want the full function and all the features of the dial, the shifting, the unshifting, the power, all that stuff, that's when you say, okay, great. I want all that stuff. I'm going to add the slider just so that I have the ability to override that unshifting. Okay. Having the slider with a Revo fit gives you all of the opportunity, all the options, right? So for those cuffs, definitely recommend using that slider.
Okay, perfect. Looks like we do have one person is typing up a question. Another one that I had, yeah, so for the slider, there's only one port that we should be using, correct?
No, like in the examples that I showed, we had the lace coming out of the dial using the A and the C port, and then I put the slider in the B port right next to the strut. And then you can use the slider basically in any port, but depends on how your lace. We recommend using either the A and the C ports for Revo Fit, or the B and the C, right?
Yeah.
And so those are the ports that in the instructions we recommend using, depending on how you're trying to orient or guide the lace out of the collar. And so whatever free port you have, that's where you would put the slider. Right. So, and typically, you're going to put it for a Revo lock. You're going to go out the C port with a lace, and you're just going to go up the socket, and you're going to put the slider in the A. Okay. You could put it in the B, but then you're kind of making like this T in your socket, and it's you're kind of wrapping around the side. as opposed to just going linear all in a row. Okay, so really depends on, you know, where can it fit, where can it go. But typically for Revo lock, slider goes into A, and that's what we instruct. The lace comes out of C, which we instruct. For Revo fit, and you're doing like a PDE, you're going to either use it in port A or port B, depending on how you're routing your lace.
I did see one question. This will be our last one, and then we'll wrap up since we're cutting close on our time here. One question that we had here is there a possibility of the insert and snap? And I believe what they're referring to is the lanyard distal attachment feature coming apart during donning. Patients commenting that they have come apart.
Patients comment that it have come apart. Okay. There has been a few that have come apart. We've remedied that with a design change. They still should have to push the button to disengage, and if they're not, we would definitely want to replace that ASAP, obviously. If they don't like the snap and they're concerned that it's going to come off, then they do have the option for a thread on. So they can use a traditional thread on and thread off if they want, if they don't like the slide. Some of the early slides or snaps that came out, people under extreme tension, because that dial can create a ton of power, at a certain angle, it could pull and pop that snap off. We've since remedied that, so that shouldn't be an issue in the future, and we've remedied that some time ago. So I would probably want to make sure that, you know, find out when that was purchased, and, you know, replace that with a threaded, you know, snap if they want, or get them a new one.
Okay, perfect. Any others, reach out to Massons for any, you know, questions, comments, concerns when it comes to any Click products. We're always happy to help. But yeah, I think we'll be kind of wrapping up here. And once again, thank you, Joe and Mike, for joining us today. Thank you, everybody, for attending. Everybody have a great rest of your day, wherever you are in the world.
Okay. Thanks, guys.
Thank you.
Take care.
Thank you, everybody.